Okay, so just a disclaimer, we will not be making a scanner, and for a Deauther, you really need a scanner if you want your Deauther to be awesome, but you can have a Deauther work if you're testing it out on your own device, which you should be doing anyways. You're not testing it out on anyone else's devices without their permission, of course, but you're gonna need to know um, target MAC address. You're gonna need to know the target's AP MAC address. You'll also need to know the channel of your, well, let me just reformat that. Target's AP, oh fuck, let me just put that channel. Target's channel, and what else? Yeah, it's actually all we need to know. So you're gonna need to know your target's MAC address, your target's AP MAC address, and the target's channel, which is really the AP's channel. But and you usually get this information with a scanner. Now, if you don't have a scanner, you can. Well, first of all, hold on. If you just want to test this out on your own device, then you won't need a scanner. You just go to your phone or go to your computer, go to the settings, the Wi-Fi settings, and somewhere in the Wi-Fi settings, you should be able to find your device's MAC address. Even if it's a randomized MAC address, which is what modern uh, phones do, it will still work. If you don't know how to do that, you can probably just go to Google or YouTube to figure out how to find your device's MAC address on your phone. But if you wanted to make this better, you can just go ask ChatGPT or ask Claude or that piece of shit Chinese whale one how to make a scanner. Well, you can just get them to make it for you. They will help you with that. Um, yeah, just make sure you're asking it to give you the target MAC address, any target MAC addresses, sorry, the target AP's MAC address and the target channel. And with this information, you can then set up your attack. So here we're doing it more manually. We're not doing an all-in-one Deauther. So I'm just gonna get that disclaimer out there before, um, yeah, before bad things happen. Later, we might have like if you see this video inside of a playlist, that means that yeah, the next video is gonna have a scanner in it. But if you don't see this video in a playlist, then I haven't committed to the idea of making a all-in-one Deauther. But yeah, so you can just go vibe code a scanner, and that should work for you. Now, before we start this, go to your board's manager, put in ESP8266, really ESP8266, and then you'll see this. Click here, this drop-down menu. Go to the very bottom. This is the oldest version. So the oldest version will allow us to access the lower level SDK's functions, which we need to perform a deauth attack. But the problem with this though, using this old version, is that it's not very it's not compatible with a lot of libraries or like things you can import. What I'm talking about is when you do include Adafruits display library.h. You know what I mean? Like when you do this, or yeah. So those might not be compatible with this old version, but later when you've done the deauthor, like finished up and you want to make something else, then you come back here and just install the modern version. So right here, it says remove. That's because I've already got this installed, as you can see there. For you, it'll say install. Just click install, wait, and it'll be installed. Cool. Also, make sure you've got your ESP8266 selected in the port. So that way, if you press verify, the compiler will understand what's going on. Okay, so this is the low level kind of SDK I'm talking about. So this header will give us some functions that we need. Go void setup. Now, first thing we want to do is make sure our radio is in station mode. We don't want AP mode. So AP mode will occupy our radio. It'll put our radio on a random channel that we don't want it on. It will also it'll send frames. It'll be broadcasting, "Hey everybody, I'm here. Join my network." By the way, and it'll also have the CPU creating responses to incoming frames. So when someone joins, like, "Hey, I'm here. I want to join." Your CPU is going to be creating a response and then sending out that frame on the radio, which we don't want. So to stop this, we are going to be like Wi-Fi set off mode, station mode. Cool. So that's what you're going to do to make sure you're on station mode. I think it should automatically be on station mode, maybe, but just in case, write this here. Cool. Wi-Fi set channel. Okay, this part we're going to talk about. So the channel again, right? Target channel. You're going to need a scanner to figure this out. Trust me, it's easy. Just vibe code one. It's not scary. It's not hard. And you'll find the channel of your target. And then once you get the channel, you can just put that in here. So maybe it'll be like 1 to 12 or 1 to 13. We'll just put in 1. I don't have a target, so you know, I'm just gonna put in 1. So I think that is all we need for the setup. Go void loop. Okay. So we'll have the Deauther stuff and a function. So we're gonna call this function from the loop. So send Deauth. And then here we're gonna have a delay. So we're gonna talk about this as well. If your delay is something like 100, which by the way, hold on, just to explain something. The value, the argument here is in milliseconds. So 1 second is equal to 1,000 milliseconds, which means that 100 milliseconds is equal to 0.1 seconds. I'll just leave that there. Hold on, one more. 10 milliseconds equal to 0.01. You knew that already. So this is 0.1 seconds. Now, you might think, 0.1 seconds, that's not much time. But actually, your phone, your target it'll like reconnect and then it'll get dual. So the effect it'll have on your target is lag. It'll just feel laggy and slow instead of them just fully being disconnected. This might depend on your target, but this is what I've noticed from my phone. So I set mine to 20, which would be, 0.02 seconds. You could set it to 1, but what I noticed about setting it to 1 is that your ESP8266 microcontroller will heat up and it hurts to touch it, which is probably bad for your microcontroller. So don't set it to 1 because it will overheat, I think. I haven't noticed any damage to my ESP8266 that I had heating up like crazy from a 1 millisecond delay, but I did not feel comfortable with it like that. So I don't know if it's dangerous. I recommend just put it at 20. Yep. Void send deauth. Okay, this is where it's fun and interesting. We're gonna need a reference for this one. Okay, let's look here. If you're interested in this website, search this up that I've highlighted. Okay, so it's coming on here. We're interested in this section here. So 802.11 frame structure and direction. Hold on, let's see. Can we zoom that up even more? Yep. I don't know if this is uncomfortably close. I don't know. Whatever. So as you can see here, actually we'll start down here. So frame control, duration, address 1, address 2, address 3, sequence control. Okay, remember these. Okay, now we can see address 4, data, and FCS. Don't worry about these. These are not going to be included. Just these guys here and 2 imaginary bytes. So let's come back here to frame control. This part is pretty important. Now, it's so important that they actually expanded on it. So as you can see, all of this information here, all these bits, are of frame control. So as you can see here, 2 bytes, right? 2 bits, 2 bits, 4 bits, that's 8. So this is 1 byte right here in these 3 fields. Then you can see 1, 2, 3, 4, 5, 6, 7. I know it's 7, and that confuses me, and it makes me feel weird. It should be 8. There's something missing here. Or maybe I have a misunderstanding, but from what I remember, there should be 8 bits. It does say 2 bytes right here, so it makes sense if it's 8 bits. But I don't know, maybe I'm missing something. Um, but we don't actually have to worry too much about this stuff here. But like super important is in this section here. Not really the protocol version. So the protocol version will stay the same everywhere, but the type and subtype, this is where it's really important. So let's come over here. So as you can see here, right, let me zoom up for you. So 0, 0 equals management, 0, 1 equals control, 1, 0 equals data. Okay, they might be wondering, okay, so there's a 0, 0, there's a 0, 1, there's a 1, 0. Can there be a 1, 1, right? Yes, it can be, but it equals nothing. So yeah, I'm just gonna leave that one out. So sorry. Now this here, this management part, as you can see, is 2 bits. This is the type. So these highlighted sections are the type. Now let me just remove this guy here. Actually, no, I'm gonna keep him. Now the deauth, what signals deauth to whoever our target is, takes up 4 bits. This is the subtype. So right here, type, it would be management, control, or data. And the subtype will be deauth in our situation. So what is the type in our situation? The type in our situation is management. Now if we come over here, management is equal to 0, 0. So 0, 0, and if we include the protocol version, which will be 0, 0, our thingy should look like this. 1, 1, 1, 1, 0, 0, which means deauth, and then 0, 0, which is our type. So here, subtype, which is deauth, and then our type, which is management, 0, 0 equals management, and then after that we've got everything else. Oh, wait, I'm so sorry, I'm retarded. These last two zeros are the version, protocol version. You might be wondering, like, might this change? Yeah, I don't think it's ever changed ever. Maybe in the future this will be like 0, 1, but currently it's forever 0, 0. So let me just fix that up a little bit. So sorry. Yep. So we've kind of got this. You might not understand what's going on here, but you should understand in a second. So let's come back to here. We need to format our packet in this way. Now, of course, as I said before, forget the address for and the data and the FCS. But let's go back to here. So we are going to create a packet. Okay, so the first byte, right? Remember, our thing is going to be a deauth, right? I want to signal that it's a deauth. Now, to get to deauth, we need to signal that it's a management type, I suppose. Hold on. So type equals management. So sorry. Management. Sorry for my spelling. And then the subtype equals deauth. And then, of course, the version. So how do we get here? Well, first we've got to do the okay. I'm saying first, but the way you read bits is backwards, kind of. It's kind of complicated. It's kind of weird and retarded, but don't worry about it. So this, the first four, will represent deauth, and then the next following, 2 bits is management, and then the next, which will always be 00, as I said, is version. So we've got these out of the way, and the version, of course. And how do we represent this in a nicer looking way? Hexadecimal. So what does that even mean? So here is our binary representation of a deauth. This is our binary, but in hexadecimal, this would be 0x C0, I think. We can confirm this if we go here. 0x 0c is 12, 1, 1, 0, 0. Oh yeah, exactly. See, I told you. Wait, did I? No, I didn't. What the fuck's going on? Binary, binary 2, hexadecimal, convert, C0, okay, yep, alright. And so instead of writing this ugly binary, we can just be like 0x C0, bingo. Sweet, that's our first byte, congrats. Now we're gonna come back here and, where are we? So remember, right, first byte, but in frame control field, there is 2 bytes. So we're gonna do all this shit. Now we don't actually have to worry about this stuff. So we're just gonna be like, okay, look here, okay, bit, right? 0, 0, 0, 0, 0, 0, 0. Okay, now imagine there's another box here and we set it to 0 as well. So how do we represent 0, 0, 0, 0, 0, 0, 0? Well, that would be 0x sorry, 0, 0, bang. 0x 0, 0, bingo, easy. That makes sense, right? So you'd imagine, right, what would happen if we wanted to represent 1, right? So this is 1 in binary. Well, in hexadecimal, it's 0x, you guessed it, 0, 1. Okay, but like, what if I wanted to represent the number 9, right, in hexadecimal? Well, it would be 0x09. Okay, yep. Now, what if I wanted to represent the number 10? Well, this is where it gets pretty weird. I think it's 0A, I think. Or maybe it's A0? Yeah, it gets pretty weird. You end up using a letter. It's kind of gross. Hold on, let's see. Hexadecimal binary. Okay, let's go. Oh, sorry. Binary no, decimal. Gotcha. How do we represent 10 in hexadecimal? Yep. Okay. So it's actually this way, 0A. Yep, it's pretty weird, it's pretty gross. I don't understand it. That's just how it is. Cool, so we've got that binary stuff out of the way. We can remove this as well. So, let's move on. I promise I'll speed up. So this is where it gets, okay, actually no, it doesn't get interesting yet. Duration. Now, we are maliciously crafting a Deauther frame. So we don't actually care about the duration. We don't care to mention that. Now this is where it gets interesting. Edges 1, edges 2, and edges 3. Okay, edges 3 is not so interesting, but edges 1 and edges 2 are pretty interesting. So this is where you put your target MAC address. So for example, my target MAC address might looks like, I mean, it'll never look like this, but this is just placeholder. Yeah, so this is your target MAC address. Now remember, you're gonna need a scanner. Go vibe code 1. It'll be quick. Okay, so when we want to deal with our target, obviously we need to address our target. So we're going to have his address in here. So his address might be, I'm just going to simplify it because I do not want to draw letters. You can see my attempt is not very good. But anyways, so his address is 0xAA. Okay, we're simplifying it to 1 byte. Now, for example, just to add some more information, the AP's address is 0xBB. Well, BBAA. I don't know what this translates to in decimal. But anyways, here is our packet that we send over. This is our packet that we send to the target. So we're telling him, hey, get off the Wi-Fi, okay? Get off, right? Now, we have his address, 0xAA, well, it's really just AA. So we have his address here, right? And now the phone knows, okay, yeah, this is addressed to me, but who's the source, right? And now our source is, I don't know. And then the phone is like, nice try, Skid, and it just rejects it. So this wouldn't work. So what we need is the AP's MAC address. So 0xBB. And now the phone thinks that because of this, the source address being 0xBB, that it's actually coming from the AP. But no, it's coming from us. The little, yeah, I'm not very good at drawing a ESP8266, but yeah, it's actually coming from us, the skid. Oh, sorry, I mean, yeah, so it's actually coming from us, the 8266. So we have to spoof the AP. We're gonna grab his address, which is why we need a scanner again to get the target AP's MAC address. So anyways, once, assuming you actually have it, we can then write his address in. Wait, have I done this correctly? 1, 2, 3, 4, 5, 6. Yeah, so just all addresses will be 6 bytes. So this is our target address. This is our source address. Usually you put your own address in there, but we're not the AP. We're spoofing the AP. I might be wondering, okay, what's next, right? So you can see address 3. Okay, why the fuck is your third address? Yeah, I know, it's pretty weird, but just put down the AP address again. So you'd think, yeah, that's about it. But no, we're gonna add sequence control. Your ESP8266 will actually control this. It'll set it up. We don't have to worry about it. Now, if we look here, the next field is address 4. Remember before I said, forget about the stuff here. That's because depending on the frame type and possibly the frame subtype, the structure changes. So we don't actually have address 4 data and FCS in our Deauther structure. What comes next is the reason, which we're just going to put down 0x00, 0x00. No, so sorry. So here, this is where in these 2 bytes you would put a reason why we deauthed you. So this would be like, yo, you're sitting on there, you were AFK for too long, you were doing nothing, so yeah, we deal with you. Or maybe, I don't know, you broke some rules, so we deal with you. Or we can just be like, we don't know the reason. If you put down 1, it'll be like, sorry, we don't have a reason. And it'll accept that. It'll be like, okay, yeah, that's totally valid. So you can just write that. But I actually don't know if that'll work. I don't know if that's... You can get away with 0. Just try this first. If this doesn't work, then put down a 1 here. But just put down 0, 0, 0, 0. So even though this is actually invalid, this is not accepted. I think it means like reserved. Maybe. But if that doesn't work, then put a 1 there. I think. Don't put a 1 there first. Just do 0, 0, and 0, 0 first, okay? And then if it doesn't work, then put a 1 there, okay? But really, I think just 0, 0 should do the trick. Okay, cool. So we've got our packet set up. Now what? Well, congrats. Oh yeah, I forgot one thing. So, Wi-Fi send packet freedom. Alright, so you'd think, right, that this would work. But no, right? You'd think that doing this, including the header file, this would give us this because we just did the same thing to this, right? But no, this thing is retarded. I don't know why the fuck this happens, but we have to redefine it. So we're gonna come up here. We're gonna be like bang. We're gonna be like and blah, blah, blah. It is integer length, and then what else? What else, boys? What else? System sequence. Okay. Oh, sorry. Boolean. Okay, so the buffer. What is our buffer? Well, our buffer is packet. Now, what is the length? Well, 1, 2, 3, 4. 4. 3 times 6. I actually don't know. 1, 2, 3, 4, 5, 6, 7. Wait, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Wait, 25? Wait, hold on. 1, 2, 3, 4, 5, 6, 26, I think. Okay, you know what? I'm not very good at counting numbers, so just go through here and count these yourself. Make sure it's 26. If it's not 26, you might be right and I might be wrong. We're just gonna be like false. Okay, I actually don't know. Do we want to say yes or I forgot? I forgot what we're supposed to put down here. I'm just gonna put it. I think yeah, false will work. So, anyways, bingo, you're gonna that works. Let's just check. Does it work? Verify. Okay. Okay. Done this before. Made that mistake multiple times. There we go. There you go, boys. That works. Now you might want to debug this. So we're gonna be like serial dot. Hold on. Okay, make sure you initiate it. Begin 11,500. Print line. Deauther frame sent. Yep, there you go, boys. By the way, if you're new to this stuff, you just go to serial monitor and then make sure over here there'll be some like I can't see it because I don't have my ESP8266 connected. But for you, there'll be some number here. It'll be like serial band or something. You want to click it and then you want to find the value 11,500 or 1. Wait, 11,000. Wait, hold on. Right, ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands. Okay, 115,200. Yeah, you want to find that number somewhere here. And then when your code is running, you should see if this is working. Deauther frame sent. You'll see a bunch of those. Now, I can't stress enough. Make sure you vibe coder scanner so that way you can actually have this Deauther effectively work. Now, I think I mentioned it earlier. Maybe I didn't. If this video is inside of a playlist, the next video will probably be a scanner, how to make a scanner. So say you somehow are struggling to vibe code a scanner, I will show you how to make a scanner. Yeah, by the way, if you look at the time for me, it's 7 a.m. Now, do you think I got up early and made this video, or do you think that I just haven't gone to sleep? Yeah, it's the last one. As you can tell, because I'm pretty slow right now. Yeah. Okay. Yep. Yep, exactly. So if there's any problems, obviously, comment down below. I will respond. As you can see in my other videos, I'm responding to comments that were 3 fucking years ago on a video that was 3 years ago. You see, I'm desperate for attention. So, anyways, yeah, comment down below. If you got a problem, I will help you. Yeah. Is there anything else to say? I don't think so. Okay. See ya.